Hi everyone, this is AI in Agriculture, one idea a day. And today we will have a discussion, very small, short as usual, not more than 1 hour. No, I am joking. It's not 1 hour, it's traditionally 5 minutes of discussing some specific question, some issue, challenge which exist in either plant science or agri-food production, which we can solve using AI technology, everything which is hidden under the umbrella of AI. So today we will speak about stomata and stomata count, just one specific task. And again, as usual, I'm a little bit repeating my topics and trying to give you some more and more details because I already have recorded the video and it will be here, where I explain how the stomata count using computer vision and deep learning works. At the same time, I will just add an extra bit. And this extra bit is created quite recently in our company in Petiole Pro. So what we have done, we have developed the module in one of our modules in the mobile application. It's a new mobile application which we are releasing soon. So it will be the stomata count on device. And what's important about this aspect? Like, why do you need to count stomatas on device? When we were speaking about stomatas, and we spoke with some scientists who are doing the research, so we were talking about the topics of plants' reaction on the change of environment, and specifically change of environment in worst case scenario when we have the heat stress or we have the water issues regarding if you have less water or more water than expected. And also CO2, it's one of the interesting parts of the game when you can just regulate the amount of CO2 and it impacts the speed of the processes inside the plant. And the behavior of stomata means signal, direct signal from the plant to understand its reaction on the changes. So let's go to this technology. From the morphological side or physiological side of plants, let's go to technologies, and specifically this is just one of the screens, because obviously, as I mentioned in previous videos, we are moving away from the idea just to help counting, because counting, it's important obviously because we need these numbers to make decisions. At the same time, the main value is not just about counting but also ability to link this number with other aspects of either specific experiment or specific production cycle. And again, regarding, for example, this photo, on top of this photo we have the variety of plant. I obviously don't show it now, but on some stage I will. Also, we have the other details and other attributes of this experiment where this photo has been taken. So as a result, the researcher has a full screen of details in one place. And we try to solve the problem of information which is just distributed everywhere. And then on some stage you try just to remember, oh my God, is it in that PDF or in this Excel, or maybe it's in WhatsApp group? I don't remember. I remember that it exists, but where it exists, it just takes hours just to find sometime the needed information. So that's why our main idea is to bring everything in one place, and obviously the photo is in the center of our universe. And that's why stomata count, we believe it's possible to do it on mobile, on edge, even without internet, by the way, because this model, it's not so heavy, so it's easy to run it on device, and you can see the result. Regarding the accuracy, basically we developed this, we fine-tuned this model based on just a few photos from very specific wheat trial. But it's interesting because these photos has never been tried before, and it's absolutely new one, and we are delighted that still our model was powerful enough to detect stomatas and even got this count, which is higher than 80% of accuracy. And this is today's idea. I hope you got some inspiration regarding what is the next step in AI in agriculture. It will be the data-centric, photocentric, and edge solutions. Thank you and see you tomorrow.